If you have ever put money in a jar that is competing for shelf space like this one, in a store, or went to greenaccessibility.com, then clicked on the Walmart link and made a purchase, or otherwise supported this project, this is what you helped to build. It is a tide pump in a pond that pumps water from a small canal located in the upper region of the tidal waters in Vermilion Parish, Louisiana. It can be applied by using tidal energy to capture sediment, then use the energy produced to distribute the sediment across the wetlands. Here is how it works. The tidal water in the canal flows into the inlet end of a 2-inch PVC plastic pipe that travels through a culvert into the pond, and exits into a flow regulator compartment. As the water rises in the compartment, it begins to flow through a pipe in the compartment wall and into a dispersion tray, where it is dispersed into the side of an impeller wheel, causing the wheel to rotate. The water then falls into a float compartment where the impeller wheel is attached to a float system, which holds the horizontal shaft of the impeller wheel parallel at a set distance above the surface of the water that falls from the wheel. As the water rises in the float compartment, it begins to flow through a one-way flow pipe in the compartment wall and into a reservoir where it is stored. When the tide reverses, the water in the reservoir flows through another pipe in the float compartment wall, then into another dispersion tray, which repeats the flow process in reverse, before returning to the canal. The impeller wheel is attached to an Archimedean screw pump by a universal joint set at 45 degrees. As the impeller wheel rotates, it causes the float compartment water to flow into the lower end of the screw pump and elevates the water to the upper end, where it is released into a trough-shaped pipe. The elevated water then flows into another dispersion tray, where it is dispersed into the side of another impeller wheel that is attached to the upper end of another Archimedean screw pump, thus rotating it as the water falls into an upper trough set beneath the upper impeller wheel. The lower end of this screw pump is set at the bottom of a containment basin, which is about 4 feet below the surface of the water in the canal. This screw pump lifts sediment at the bottom of the basin and releases it into the upper trough. When the rising elevation of the canal water is 5 inches above the float compartment, the impeller wheel will rotate until high tide, and continues to the height of a flood. It does the same in reverse. The sediment is captured by a siphon in a pipe, which is designed as follows. A shallow hole is dug in the bottom of the canal at the end of the culvert. An 1.5-inch PVC pipe is placed at the bottom of the canal hole to serve as an inlet for the siphon. As the siphon water travels through the culvert, it picks up the sediment at the bottom of the canal hole and releases it into the containment basin. The siphon is started and maintained by filling a horizontal 4-inch PVC pipe with water, above the siphon pipe, then releasing the water into a 1-inch pipe downward into the flow regulator compartment. This creates a vacuum in the 4-inch pipe. Attaching another 1-inch pipe from the top of the 4-inch pipe to the top of the siphon pipe, will vacuum the air out of the siphon. This will pull the water from the canal into the pipe and start the siphon. Installing a knife valve will stop the siphon. The water from the float compartment screw pump also flows into the inlet of the 4-inch pipe that keeps it filled. The water and sediment in the upper trough is released into a pipeline, then distributed by the gravitational force produced by the upper elevation. The tide pump is a work in progress. An automated system and a wind pump is in development.